Welcome to Class TV. I read myself, Alewi Tosin. Now, this is part 4 of equilibrium of forces. In this part, we are taking the concept of what? Center of gravity. Now, what is center of gravity? Before I define that, as a student, when you have your notebook with you, now try to look for a place, a point in your notebook where you can just hold with just a finger under it, and the notebook will be at equilibrium and it will not fall. What am I trying to say? Let's assume this ruler is your notebook, right? Try to put your hand at the middle. There's a point where when you place your finger, the notebook will not fall. It will be balanced. Now, that point is the point where that point is always at the middle of your notebook, and it is the point where the entire weight of the notebook is concentrated. That's the point where the entire weight of the notebook is concentrated. That point in your notebook is referred to as what? As the center of gravity. Now, in a ruler like this, there's a place I will place what you call a fulcrum, or we call it what? A knife edge. That this ruler will not shake, and it will balance. You see that? Now, this point in the ruler is referred to as what? The center of gravity. So how do we define center of gravity? We say center of gravity is the point in which the entire weight of a body is concentrated. Is the point in which the entire weight of a body is concentrated. When the entire weight of a body seems to be concentrated at a point, just like the one I explained to us now, we say the resultant gravitational force of a body appears to act at that point. Resultant gravitational force of a body appears to act at that point. In a sphere, the center of gravity in a spherical object is always at the center of the object. It's always at the center of the object. That's the point where the weight of the body rests, is more concentrated. In a triangular shape object, this is the center of gravity is said to be at the point where the diagonals intersect. Where the diagonals intersect. So this is center of gravity of a regular triangle shape. Now, for a rectangle, just like your notebook, I cited an example. Now, the point of intercept of the diagonals, are you together? Is our center of gravity. Let's denote it as by CG. Is the center of what? Center of gravity of that object. Now, the center of gravity of a body depends on two things: the shape of the body and the size of the body. It depends on two things: the shape of the body and the size of the body. The position of the center of gravity changes with the changes in the shape of the body. As the shape of the body changes, the center of gravity also changes. Now, I also want to cite an example again. Tell us that in a uniform rod, before I proceed to, let me also make it clear to us. The meter rule we use in the laboratory has the length of 100 centimeters. You can confirm that. 100 what? Centimeters. Now, civil question will not tell us the length of a meter rule because they expect us to know it as it was a physics what? Student. Now, the center of gravity of a meter rule is at the middle of the what? Of the meter rule. What does that mean? The center of gravity of a meter rule is at 0.50 centimeter of what? Meter rule. Now, if the meter rule is like, if they say half meter rule, if it is half meter rule, it means that what? The meter rule is of length 50 centimeter, and it means that if it is half meter rule, the center of gravity will be at what? 25 centimeter. Let's take note of that because of for our future calculations. Now, in the uniform rod or beam, the center of mass, there's what's called center of mass. What is center of mass? Center of mass can be defined as the point at which an applied force produces acceleration but no what? Rotation. An applied force produces what? Acceleration but no what? Rotation. That's what we call our what? Our center of mass. Okay? Our center of mass. Center of mass. Okay? Now, we said that in a uniform rod, the center of mass and the center of gravity coincides because the mass per unit length is the same along its whole length. What are we saying? The mass per unit length of a meter rule is the same but along the whole what? Length. The size is equal all through, and the mass at every point are what? Are the same. So at this point, you say that what? In a uniform meter rule or uniform rod, you say that what? The mass, the center of mass coincides with what? With the center of gravity. And also take note, the higher the center of gravity of a body is, the more easier it is for the body to fall. Example, as a short boy will not fall easily. A short football player will not fall easily because his center of gravity is what? Is lower. Is very low to the what? To the ground. It's closer to the ground. But a tall football player has a tendency of what? Of falling easily because what? His center of gravity is at the middle of his height, and it is what? Farther away from the ground. So in this case, we say that what? And that is why a tall footballer has the chance of falling easily at any displacement than a short footballer. We'll be taking more of it in our next class. We'll be talking about equilibrium stability. I name myself Aliwi Tosin. Let's meet in our next video. Thank you.